Hi, this is Mrs. Vrobel. This is Chapter 14, Mixtures and Solutions, Part 3. So in this video, we're going to correctly determine if a solution is saturated, unsaturated, or supersaturated. And then we will precisely determine the factors that affect solubility. And then lastly, we're going to accurately determine the solubility of a gas in a liquid using Henry's law. Okay, so what is solubility? Solubility is the amount of solute that is in 100 milliliters of water. So this is from my last video where I have the sugar cube, and you might notice that a lot of the sugar cube has dissolved. There's just a little bit left here. So my question to you is this saturated, unsaturated, or supersaturated? Now let's look at factors that affect solubility. Temperature. You may have noticed that when you are cooking that sometimes temperature will affect how much dissolves in a liquid. Surface area. Remember how I was talking about the sugar cube? So the sugar cube, what happens to it based on the surface area? And then lastly, agitation. That means stirring or maybe shaking the solution. Okay, so unsaturated solution. It is a solvent that contains less than the maximum amount of solute. So my question to you is this unsaturated? Saturated contains the maximum amount. So you cannot get any more solute to dissolve in a liquid. You probably noticed that when you're making sweet tea that you can only add so much sugar, and then if it's too much sugar, it's not going to necessarily dissolve. It'll just remain at the bottom of the cup. And then lastly, supersaturated. So in class, I'm going to show you an example of a supersaturated solution. And this is more than the maximum amount of solute dissolved. Okay, supersaturated solutions are unstable. You're cramming in as much solute as possible with the solvent. As a result, you may get a suspension as opposed to a solution. The way you can get a supersaturated solution dissolved is, or undissolved I should say, is when you can scratch the surface of a container. Sometimes just dirt or adding a crystal of the solute will cause it to come into solution and almost form a suspension, not a solution. Okay, so you're going to be doing a lab where you look at solubility of a solid based on temperature. And you might notice that in this graph here, there's different curves. And this one is very unusual here. Instead of it having a positive slope, it actually has a negative slope. And I want you to think about, why would something have a negative slope if you increase temperature? Because most of the time when you increase temperature, notice how the solubility will increase. Okay, all of these curves have increasing solubility with a higher temperature. However, this one does not. Okay, so a saturated solution, we're talking about solutions that have the maximum amount of solution. It's important to remember that it's in equilibrium. So the amount of solute being dissolved is equal to the amount of solute that is trying to come out of the solution and form a precipitate. Question is, how do you know that something's saturated? What are the conditions for that saturated solution? And lastly, how do we define it on the molecular level? Okay, so factors that affect the rate of dissolving for a solid. You need stirring. So you're probably going to notice in the lab, if you don't stir properly and you just let things sit at the bottom of the solution, you will not get the dissolving that you need. Temperature. The more you raise the temperature of a solvent, the more readily the solute will dissolve. And then lastly, surface area. If you keep solute clumped up like the sugar cube, it's going to take longer for the solute to dissolve. Okay, so let's talk about gases. Please note that solubility of a gas in a liquid, and we'll talk about this in class when I bring my soda stream in. We're looking at temperature. So temperature affects how much gas can be dissolved in a liquid. Pressure. So when you put pressure over a liquid, that actually could change the amount of gas dissolved. And there's what we call Henry's law. So Henry's law, we're looking at the solubility of a gas at a specific temperature, and it's proportional to the pressure exerted above the liquid. Here's the formula that we typically use with Henry's law. Notice it's S1 over P1 equals S2 over P2. Okay, so here's a problem that I'm going to do with you here, and we're going to use that formula that I just talked about. So if we have a solubility of 0, 1, 2, 3 molarity at a pressure of 1.18 atm, they want to know what the solubility is. So what is the S2 divided by 355 atms? So I'm going to set this up. So S2 equals 0.0123 atm. I'm sorry, no, not atm, molarity times 355 atmospheres divided by 1.18 atmospheres. So when you solve for this, you should get 37 molarity. Okay, and I want you to try number 2 on your own, see what you get, and we'll go over that in class. Okay, so in summary, solutions that are saturated contain the maximum amount of solute dissolved in a solvent. If you have an unsaturated solution, like my solution here is probably unsaturated because all of the sugar cube is gone. Supersaturated typically are unstable and contain more than the maximum. And then lastly, Henry's law, we're looking at a given temperature, the solubility of gas is proportional to the pressure above the liquid.